cool. All right. So what I just want to go through now is the comparison that you're going to need in order to get the excellence on this assessment. So we're talking about the electrolytic versus galvanic comparison. And this is what you need for E. If you're not aiming for excellence, then you don't have to worry about writing this comparison. You're fine to stop with the galvanic cell, write up, and then you're done. Some things to keep in mind is that this is mainly just a chance for you guys to compare and contrast the difference between these two cells. For the purpose of the notes and for the purpose of making it quick, I'm just going to do a Venn diagram, but when you guys write it up on the assessment, I'm going to give you some refill and you write it like a paragraph setting. Does that make sense? So this is just notes for shorthand. Draw 2 circles. Oof, those are terrible circles. I should have just printed out some circles. All right. So just note that I'm doing a Venn diagram for shorthand. You write it as a proper paragraph. Don't be lazy like Miss Garlic, okay? Yeah? All right. So we are thinking about our electrolytic cell and our galvanic cell and what makes each one of those unique and what makes them similar. And the center will be both. So something to start off with when we're thinking about both of these reactions are redox reactions. And when we're talking about these redox reactions, we still have the same when it comes to the cathode and the anode. So cathode equals reduction, and the anode equals oxidation. So that doesn't change when I swap between these two cells. Are we good so far? Yay, nay? Yeah? All right. Now, some things to keep in mind, though, is now what are the differences between these two things? The first thing, what's really obvious for us when we think about these two cells? Huh? Positive and negative. So when we do the electrolytic cell, the E cell calculation equals a negative number, whereas the galvanic cell, the E cell calculation, is going to be a positive number. What does that mean to us? What does the positive number mean? Spontaneous. What does the negative number mean? Non-spontaneous. So, some things to keep in mind then, since we're talking about E cell being spontaneous and non-spontaneous, with the non-spontaneous, we are starting with electrical energy coming from the plug, and we are converting it into chemical stored potential energy. What's happening with my galvanic? What's my energy change then? Chemical to electrical. It's the opposite. And that's why we can use this as a battery. We good so far? So we know it's spontaneous, it's chemical to to electrical. With our galvanic cell, in this case, when we try to figure out what's going on with that reaction, what do we do? When we start this reaction, what are we looking at on our sheet? The standard reduction potential, and the one with the higher one is our stronger oxidant. So for the galvanic cell, we check standard reduction potential, and the more positive is the stronger oxidant. So in this case, this one is going to be, like I said, that's spontaneous because it's just doing that redox process on its own. For the electrolytic, though, it is non-spontaneous, and so what I need is energy to force the reaction to occur and reverse the flow of the electrons. Now, if you guys remember on your assessments, I realized that I didn't give you guys that statement, and so you're going to have to need to make sure that's in your paragraph when you're doing comparison for the excellence. So that's why I put a little star there. We need to talk about how we need to supply energy to force electrons to move in the reverse of the natural direction. So that's something that I forgot to mention that I need to see in your essays. So we need to supply energy to force the electrons to move in the reverse of the natural direction. The natural direction would be the spontaneous reaction. That's why we're forcing it backwards. We okay so far? All right. Thinking about the setup of the experiment, how many beakers did I have for the electrolytic? 1 beaker. How many beakers did I need for the galvanic? 2. Why did I need the 2 beakers? The bridge, the salt bridge. Yes, we needed 2 beakers. We also needed the salt bridge. Why did I want to separate that reaction, though? Why didn't I just mix it all together in 1 beaker? To control my flow of electrons. So this one here, we are dependent on the natural flow of electrons because it's a spontaneous reaction. This one here, we are making sure that the natural flow of electrons doesn't occur. We're forcing it backwards. So that's where these kind of work as a comparison. I think we got most of them except the charges of the electrodes. Any questions so far? No? All right, last thing we had here were the charges of the electrodes. So just being mindful that the charge of the electrodes change. So cathode still reduction, anode still oxidation. But in the cathode, the galvanic cell is going to be positive. That's going to be our positive electrode. And the anode will be the negative electrode. In the electrolytic cell, it is the opposite way around. The cathode is the negative electrode, and the anode is the positive electrode. So that's just another point of comparison, is just the electrode themselves, what labeled charge they get. And that just depends on how it's hooked up to the battery or the flow of the electrons. And that's basically it for that comparison. So this is kind of the summary notes of it. What I want you guys to do is take this and make it obviously a nice coherent paragraph. Think about the NCA kind of essay structures and thinking about how you can write a comparison. So you'd be like, even though both electrolytic cells and galvanic cells are examples of redox reactions and reduction happens at the cathode and oxidation happens at the anode, they are 2 very different reactions because, and then start explaining why. You don't need to tie it back to the specific examples of the assessment. We are just talking about general comparison of electrolytic and galvanic. The other thing to think about with electrolytic and galvanic is that electrolytic cells are basically our batteries, whereas the galvanic cells are our batteries. The electrolytic is used to purify elements or to do some electroplating. It can also be used to recharge batteries. So again, if we're thinking about the link between these two, if we're thinking about, what is it? Let's say we have our cell phone. Our cell phone is an example of a galvanic reaction. It's automatic, it's spontaneous. We can use the chemicals that are stored in our battery of the cell phone to then do electrical functions to get our phone to work. But obviously we run that battery low and down, and eventually we flatten our battery. And in order to recharge your cell phone, you got to plug it into the wall and force it to do the electrolytic and undo that spontaneous reaction, so that way you can use your phone again. The downside is eventually all of these batteries will degrade over time, because you can only do that back and forth reaction so many times, and then the battery itself just can't do it anymore. So that's why you notice as your cell phone ages, it's not doing that recharge process as efficiently and as well, so the batteries in your cell phone don't last anymore, and that's why you have to replace it. The car battery has the same sort of idea. You have a galvanic spontaneous reaction with the car battery to get the spark, to get the engine to go, and then the battery in your car recharges it using something called the accelerator when you're driving. So when you're driving, you're recharging your car battery. So if you ever get a flat battery, jumpstart your car and drive on the motorway for a good 20 or 30 minutes to recharge the battery. Because if you turn on your car after you jumpstart it and then you just drive to the supermarket and you turn it off, you haven't given the alternator enough time to recharge the battery, and your car's going to die again. So just a little mechanical advice if you guys are driving. So yeah, that's everything. I'm mindful we got 5 minutes left. So I'll try to quickly check additional work. The plan is for Friday. I think you guys are ready for your galvanic. You're shaking your heads no, but I've been looking at your work and it looks fine. Remember, galvanic, I'll give you the first attempt, and then I'll give you feedback, and then if you need another attempt, we can do another attempt. Cool. All right, that's us. Do you guys want to keep working? You want free time for the last 5 minutes? Want to bank it? All right, then keep working.